Yeah, hello guys. Welcome back to my YouTube channel. Preeti this side, and today we are going to learn about one of the most useful and time-saving techniques in programming, that is a sliding window. So, if you have ever struggled with problems that involve subarrays or substring, especially those asking for sums, maximums, or minimums, this technique is going to be a total game changer for you. So, so what exactly this sliding window is? So, imagine you have an array. This is one array. You can see on the board 2, 3, 5, 2, 9, 7, 1, and you are told to find something for every subarray of size k. To find something, you can maybe a question would be like this: find a maximum sum of subarray of size k. Maximum sum. Okay, so maximum sum, if I like subarray of size k, means you can assume like k equals to 3. Okay, so window size would be 3, and we have to find of all the subarrays of size k, and the maximum of all the sum we have to return it. Okay, so when I say like subarray, when subarray means it should be continuous. So when I say k equals to 3, means you have to take 2, 3, 5 continuously. Then 3, 5, 2 is also one of the subarrays. 5, 2, 9, 2, 9, 7, and 9, 7, 1. It's not like that you have to take 2 from here and 7 and 1 from here. It should be continuous, not discontinuous should not be there. So subarray means continuous. So have you noticed something here? Each subarray is continuous, and as we move forward, like this is one of the window. Okay, and we move forward here, like first 2, 3, 5, then we have 5, 3, 5, 2. So as we move forward, we drop one element means when we go from here to here, we drop 2, and we have added 2 here, right? So we are adding one new element at the end, and we are removing one element from the start. So actually we are sliding, right? We are going, this is one of the window, this is one of the window, we are sliding. So this window, this approach is known as a sliding window. Okay, so before we go to sliding window approach, let's see if without sliding window how we can solve this, right? So if I ask you to solve this one, so what we can do, like suppose if we have array is 2, 3, 5, 2, 9, 7, 1, right? This is the array. So what you can do, and we have a window size k 3 equals to 3 is given. So what we can do, we can use a one for loop, outer for loop, that will go from 0 to n minus 1, where n is the size of the window. So 0 to 6 or 0 to n minus 1. So outer loop will go from 0 to n minus 1, and then for each index of outer loop, it will go till the window size. Means inside loop will go from I equals to index j equals to I to k minus actually k, right? So example, so it would be like this: 2, 3, 5, 3, 5, 2. So these will be our subarrays, and if we calculate like this, this will give 9, this will give 10, 16, and this will give 18, and this will give 17. So maximum of these are 18, right? Maximum is 18. So this would be the answer. So We can solve this using the naive approach also, but if you see this approach actually, what would be the time complexity? Means outer loop it will go from 0 to n minus 1, means n, big O of n, and inside loop it will go till the size of the window size, right? N into k. So time complexity of this naive approach would be n into k. Now if we follow the sliding window approach, obviously its time complexity will be reduced. How? Like if you can see, we have 2 3 5 3 5 2, right? So we have something called this is 3 5, like we are just adding the 2, we are just removing the 2, and we are adding the 2 at the end. This is something which is we are repeating. So if we can, is there anything we can reduce? Is there any improvement we can do? So when we move our window forward, right, we remove the first element and the next we add the next new one. For example, if we are going from 2 3 5 or 3 5 2, we are removing the 2 and we are adding the removing the 2, adding the 2. So here we are removing, here we are adding, right? So this tiny change is avoiding the redundant work. We are not doing anything for this one, right? So this approach will make our algorithm much faster, right? So for this, if we calculate, our time complexity would be big O of n only. We just need to traverse from 0 to 6, and we have to find something like we can, in the sum we can remove the first one and we can add it. So we are just reducing the repetitive work. So in this approach, we start by calculating the sum of the first window. We'll calculate the sum of the first window, and then for each step we are subtracting the element that slides out and we are adding the new element that slide in. Okay, so this from big O of n into k to big O of n, this is a very huge improvement in time complexity. So now the question is next, how do we know when to apply the sliding window technique? So there are usually two types of hints I can give you. Like if you are dealing with sub-arrays or substrings that are continuous, means in the question if they are telling you like this is sub-array or current substring, obviously it will be continuous sub-arrays, right? And you need to find something like a maximum, minimum, or sum of those sub-arrays. So in both the condition, what actually, yeah, if those conditions are true, then you can think of a sliding window. Okay, so yeah, in sliding window we have actually two main types. Like types, if you ask about the types, we have two types. One is the fixed one and one is the variable. Okay, so when I tell you like fixed one means window size will be given, it would be already there, and you have to find, example, find the maximum sub-array of size k, right? So in fixed, what type of question you will get? You will get find maximum sum sub-array of size k. K would be given, like it would be anything, right? So, and in the variable size, the question would be something like they will not give you a window size yourself, and they will give you some condition and you have to find the window size only. For example, find the smallest sub-array. Smallest sub-array means they are asking you to find the size of that array with sum greater than or equal